In this video, I am going to solve the problem 53 from chapter 19. In a certain particle accelerator, proton travels around the circular path of diameter 23 meter in an evacuated chamber, whose residual gas is at 295 Kelvin and 5 multiply 10 power minus 7 torr pressure. First question, calculate the number of gas molecules per cubic centimeter at this pressure. And the second question is, what is the mean free path of the gas molecules if the molecular diameter is 2 multiply 10 power minus 8 centimeter? So here we have to answer for two questions. In the first part, we are going to calculate the value of N over V. So N stands for number of gas molecules and V stands for volume, but we have to give the answer in terms of the molecules per centimeter cube. We should not give the answer in terms of molecules per meter cube. They need the answer in terms of molecules per centimeter cube. And the second question, we are going to calculate the value of mean free path of the gas molecule, which is a lambda. So now I'm going to write the given first. So what is given in the question? In the question, they give the information about the circular path diameter, because here the proton is travel around the circular path. Its diameter is given here. So let's we take this diameter as capital D, which is equal to 23 meter. And also they mentioned the temperature. Here the temperature they mentioned as 295 Kelvin. And also they mentioned the pressure, but the pressure here is in terms of torr pressure. So we have to convert this torr pressure in terms of Pascal. So we have the conversion. By using that conversion, we can easily convert this torr pressure in terms of Pascal. So what is the value of the pressure here? 5 multiply 10 power minus 7 torr pressure. Okay. And also they give the molecule diameter. So let's we take this diameter as small d, 2 multiply 10 power minus 8 centimeter. So in terms of meter, it is 2 multiply 10 power minus 10 meter. So now better we can convert this torr pressure in terms of Pascal. So if you want to use the conversion, then only we can convert this torr into Pascal. So 1 torr, which is equal to 133.3 Pascal. So here we have 5 multiply 10 power minus 7 torr we have. So what should be the value in terms of Pascal? So here we have to cross multiply for getting the answer in terms of Pascal. So by that we will get the answer of the pressure in terms of Pascal as 6.665 multiply 10 power minus 5 Pascal. So this is the value of the pressure in terms of Pascal. Okay, let's start the first question. So here they need the answer for the number of molecules per centimeter cube. So that means N over V value we have to calculate. So for this, I'm going to use the ideal gas equation. So what is the ideal gas equation? Actually, we have two different models of ideal gas equation. One is PV, which is equal to nRT, and the second model is PV, which is equal to nKT. Actually, we got this model from this one. Okay, so actually we have to substitute some formula here for getting the value of this small n in terms of capital N. Here small n refers to the number of moles, but here capital N refers to the number of molecules. Okay, so for this question, I'm going to use this equation, which is PV equal to nKT. So I have to rearrange this equation in terms of N over V. Therefore, N over V, which is equal to P over KT. Now I am going to substitute the value because we have all the information. So pressure, just before we converted the pressure of torr in terms of Pascal, which is 6.665 multiply 10 power minus 5. And the temperature they mentioned here as 295, right? And also the Boltzmann constant is a constant, which is 1.38 multiply 10 power minus 23 joules per Kelvin. So it's a constant value. We can directly use that value here. So 1.38 multiply 10 power minus 23 multiply with 295. I got the answer for N over V as 1.64 multiply 10 power 16 molecules per meter cube. But They ask us to calculate the value of this N over V in terms of molecules per meter cube. As we already studied the conversion, 1 centimeter cube, which is equal to 10 to the power of minus 6 meter cube. So if you use this conversion here, we will get the answer of N over V, which is equal to 1.64 multiply 10 power plus 10 molecules per centimeter cube. So this is the answer they just need in the question. So they ask us to calculate the value of N over V in terms of molecules per centimeter cube. But when you come for the second question, I'm not going to use this because the molecular diameter they give a centimeter, but I will convert that molecular diameter in terms of meter. By that, I have to use the value of N over V in terms of molecules per meter cube. Clear? Okay. Now we have to go for the second part. So what is the rule for the mean free path? We solved many questions in the previous videos. The mean free path is given by the rule lambda, which is equal to 1 over root 2 pi d square N over V. This is the rule for the mean free path. So now we have all the data here. I'm going to substitute the value 1 over root 2 multiplied by pi, and the molecular diameter is, I mentioned in the question, what is the value of the molecular diameter? The molecular diameter small d here is 2 multiplied 10, because I converted the centimeter in terms of meter cube. So 2 multiplied 10 power minus 10 meter. 2 multiplied 10 power minus 10, but this is square, so I have to square this value. And N over V value, because I already convert this molecular diameter in terms of meter, so I can't use this one. So I have to take the values of N over V in terms of molecules per meter cube. So I have to use this value 1.64 multiply 10 power 16. 1.64 multiply 10 power 16 I have to use here. So I calculate the value of mean free path. I got the answer here as 343.12 meter. So this is the answer for the second part. That's it. Thank you.